Welcome back everyone to our journey into trig. So this is lesson 11. We're going to now start solving with trig, but specifically in this lesson we'll be solving for the sides of a right triangle using trig. Now what's nice is we will only be using the three basic trigonometric ratios. So essentially just SOHCAHTOA. So as you recall from lesson 10, we learned about SOHCAHTOA and what it represents. First, you need to have a given angle in your right triangle. So let's say this bottom one down here is my given angle. We then label the sides of our right triangle. We know that the side opposite the right angle is our hypotenuse. Then the side touching the given angle is our adjacent. And then the side that's across from the given angle is our opposite. So you need to know the sides of your right triangle in relationship to your given angle. So SOHCAHTOA is sine of theta is equal to opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse, and tangent theta is equal to opposite over adjacent. So we're going to be using our calculator and our trig functions to be able to solve for a side of our right triangle without using Pythagorean's theorem. So our concept today is find a missing side length. So to find a missing side length, we set up one of the three trig ratios, and then we're going to solve for a variable. So our theta, our given angle, is actually going to be an angle in degrees. As you can see here for our first one, it is 50 degrees. So that is our given angle. So we look here, we still identify the two sides that are given to us. 12 is opposite, x is adjacent. So we look up here, which trig function uses opposite adjacent? No, there we go, it is tangent. So we have tangent. Now, instead of writing tangent theta, we're actually going to write tangent of 50 degrees is equal to opposite over adjacent. And now we have to solve for x. I'm going to give you guys a really nice shortcut here. If, when you set up your trig ratio and the variable is in the bottom, all you have to do is flip-flop the trig function with the variable. So x is equal to 12 divided by tangent of 50. And now we just go to our calculator. The big thing you have to make sure is that your calculator is in degree mode. If it is not in degree mode, you need to change the mode. But all we would have to do now is just 12 divided by, and as you can see on my calculator, there's the tangent button, tangent of 50 degrees, closing all parentheses, and there we go. So yes, you are going to get a lot of decimals. Our notes say to round to the nearest tenth. So we get x is equal to 10.1. All right, our next one. So our angle is 43 degrees. And then again, in relationship to this, we have 3 is our hypotenuse and x is our adjacent. So for adjacent and hypotenuse, we're going to use cosine. So the cosine of 43 degrees is equal to the adjacent is x, hypotenuse is 3. When the variable is on top, well, we just multiply both sides by the bottom. So 3 cosine 43, 3 cosine 43, and there we go. X is equal to 2.2. Now, on some of your problems, you will not have the triangle set up for you. So, we have to set it up. In these ones, I just do a basic right triangle. Your right angle is always C. You can decide what you want your angle A or B to be, but I just like A, B. So they tell us angle A is 35 degrees, and length C, which is across from angle C, so that's 6, and we want to find little b. Little b is always the side opposite angle B, so I'm going to put that in red, what we need to find. So here is our given angle, 35 degrees, and we have adjacent and hypotenuse. Adjacent, hypotenuse. So this is another cosine. So cosine of 35 degrees is equal to b over 6. Multiply both sides by 6. So 6 cosine 35, and we get 4.9. So if they do not give you the right triangle, draw your own. Here, I'm going to draw another one. And there, all my right triangles are going to look the same. I have them all labeled the same. It's just the easiest. Pick a right triangle that you like. So we want to find C, which we know is our hypotenuse. Angle B is 70 degrees, and A is 6. Well, looks like we have another adjacent hypotenuse. So this is going to be another cosine. I did not do this on purpose. That just is what happens when I grab examples. So 6 over C. When the variable is in the bottom, again, this is just one where we flip-flop. So C is equal to 6 divided by cosine 70. So 6 divided by cosine, oh, you can't see that, 70 is equal to 17.5. So there we go, some basic solve for sides. It is very, very important that you understand how to set up a right triangle, but also how to identify what is given to you. Is it, what's your given angle? What's your opposite? What's your adjacent? What's your hypotenuse? If you can't get it set up, you will not be able to do these problems, so you need to make sure you know how to set up your right triangles. All right, now we need to look at some word problems. These types of problems are called angles of elevation and depression. So the angle of elevation is when you are measuring the angle from the floor or the ground, and the angle of depression is when you are measuring from a ceiling or a height. Here's another way to think of elevation and depression. Angle of elevation is when you are looking up, and you would have a right triangle like this, and your angle of elevation is right down here. So think of it as looking up. Angle of depression is like if we were looking down. So if we are looking down, it's like we're going to have like an upside down right triangle, and our angle of depression is up here at the top. So use these two right triangles, and it's up to you to determine, is the problem looking up or is it looking down? And we're going to dive into those problems on the next